In this video, I'm going to show a demo of testing a Java application with Filibuster using jUnit. For this sample application, I have a hello service that has a path called /world. When you make a request to this, it will make a request to the world service, and if it gets a 200 back, it will return hello world to the user. And so what I've done is I wrote a functional test here. I'm going to run this test with coverage, so just we can see what this looks like. And my test simply will start some services. It will make a request to the hello service on the port it's listening on to /world, and it will assert basically that the status code that it gets back should be 200. So this is kind of reminiscent of like a standard integration test that a service would run. And if we take a look at the coverage here, we can see that basically we've covered everything, the golden path execution, except for this error handler for when the status is not 200. And so we have some untested error handling code, and we have some error handling code that maybe we need that we haven't written yet. So to test this, I'm going to start by adding the Filibuster instrumentation library. And then I'm going to manually instrument our service to use Filibuster. Now, we do have a mechanism in Filibuster for automatic instrumentation, but that will automatically instrument all calls. And so since most people want to try Filibuster out before they adopt it wholesale, I'll show how you can do that. So here, what we're going to do is attach a decorator to our HTTP client that will allow Filibuster to see the HTTP calls that are being sent between hello and world. And then simply what I do here is I'm just going to update my test annotation to the Filibuster test annotation, which is going to use a default configuration of some errors to inject for the RPC between hello and world. Now what we see here is that we've generated a number of tests, and some have failed. So here's an example of where we injected a 503, and it causes our system to return a 424 instead of a 200. We see another one here. This looks like it was a 502. And so we're going to start by first solving that issue. So we know that this is coming from this untested line here, in that if the status code is not 200, we'll return a failed dependency. But our test here doesn't currently consider that case. It only considers a successful case. So we can use a helper provided by Filibuster called wasFaultInjected. We'll import that static method there. And we'll say that in the case of a fault being injected, we want to assure that status code is 424 failed dependency, which ensures that we capture the behavior when our system fails. And then we'll say if a fault wasn't injected, we assume that we will get the 200. So here, what we can do is rerun our test. And we see we got a little bit farther, but we still have a failure. In this case, we're getting a 500 internal server error response, and we're expecting a 424, which means that we hit this code where a fault was injected. And this is because what happens here is in the hello service, this call can actually throw a runtime exception that we're not checking for. So here I want to capture for this, and I want to say if cause is not equal to null, just going to generically handle all of the failures. Then I'm going to return the HTTP response of failed dependency. Now this is necessary because the way the Armeria client works, and this is just a special case of the Armeria client, what the Armeria client will do is you have this handle function, which is a callback, and this will be your HTTP response. And if call is not null, that means a runtime exception was thrown inside of this HTTP request. So we're going to say that if the cause was not equal to null, which means that there was some runtime exception raised, then I should return this failed dependency as well. So we'll rerun our test. And now what our test should do is exercise the fault injected case for the different 500 variations of status codes, as well as the exceptions that can be thrown. And it will only assert 200 when no faults are injected. And we see here that when we run this, it passes. So now what I can do is I can go back and rerun my coverage utility. And we could have been doing this throughout the entire process. We just didn't because it takes a little bit of time to generate those coverage reports, and import them into IntelliJ. So we'll just wait another minute for our test to finish and the coverage report to be generated. Now, if we kind of go back and we look at our Hello server, we can see that we not only have covered the failure handling code that we didn't have tests for, but we also had to write some additional code, which is covered because our test generated a case that drove us into this scenario. And so this is an example of how developers can, right within their IDE as part of their development process, start learning about building services, building resilient services that can handle particular errors, and it integrates nicely into the existing coverage utilities that are provided by jUnit. Now, like I said at the beginning, often you don't want to manually instrument your services. In a future video, I'll show how you can automatically do this using a Java agent that we've created that will instrument HTTP using Armeria and Google's gRPC using the standard gRPC client or any client that reps that. And we can explore some of those errors that way. And then finally, what we've done here in this one particular test is test for a default set of errors that Filibuster assumes that everybody wants to test for. But there's also a way to provide a custom configuration to say that I want to test for a very particular set of gRPC codes or a particular set of HTTP codes. So all of that stuff's configurable. This was just a demo of kind of what you get out of the box and how easy it is to get started. Thanks.